Find the probability of rolling doubles on two six-sided dice numbered from 1 to 6. Numbered from 1 to 6. So let's just think about it. Let's think about all of the outcomes, all of the possible outcomes, and then what fraction of those outcomes represent us getting doubles. We want to roll doubles. So let's make a little table here that'll give us all of our outcomes. You have 6 outcomes on the first dice, or the first die, I should say. So 1, 2, 3, 4, 5, 6. So let's call this the first die. First die. And then the second die, there are 6 outcomes. So 1, 2, 3, 4, 5, 6. This is the second die. Second die. So all of the different possible outcomes are going to be you're going to get an outcome so you could get a 3 over here, and then when you get a 3 on the second die, you might have gotten a 1, 2, 3, 4, 5, or 6 on the first die. Or you might have gotten a 5 on the first die, and then you could get a 1, 2, 3, 4, 5, or 6 on the second die. So if I draw a grid here, if I were to draw a grid here, let me do my best to draw a quick grid. Just draw it really fast. So let me just draw this grid right here. Each cell of this grid, each box in this grid would represent an outcome. Each box in this grid would represent an outcome. All of the possible outcomes. Let me finish drawing it. So there you go. And so just to get an understanding what I mean by it represents an outcome, this cell right here would represent getting a 4 on your first die and a 2 on your second die. That's the outcome it represents. It's one of the potential outcomes. Now, how many total outcomes are there? Well, you could look at the area of this right here. The area of this is going to be 6 times 6. You have 36 possible outcomes. So 36 possible outcomes. And it makes sense. You could think about the first die. There's 6 outcomes, and then for each of those 6 outcomes, you have 6 possible outcomes for the second die. So 6 times 6. Or you can think of it in this grid, it has exactly 36 cells in it. Now, what are the outcomes that satisfy our conditions that entail us getting doubles? What are the outcomes there? Well, we could get a 1. If we get a 1 on the first die, we have to get a 1 on the second die. If we get a 2 on the first die, we have to get a 2 on the second die. We get a 3 on the first die, we have to get a 3 on the second die. I think you see where this is going. 4 and 4, 5 and 5, and then 6 and 6. So how many of these outcomes involve us getting double? Well, it's 1, 2, 3, 4, 5, 6 outcomes. So there's 6 outcomes with doubles. So if someone asks you, what's the probability? What is the probability of getting doubles? Probability of getting doubles when you rolled two six-sided dice numbered from 1 to 6. It's going to be equal to the number of outcomes that give us doubles. So it's going to be equal to 6 over the total number of possible outcomes, over 36. And 6 over 36 is 1/6. Now, I made sure that you kind of understood that, look, these are all the possible outcomes, and then these 6 of them satisfy, so 6 of the 36. So there's a 1/6 probability of rolling doubles. But another way you could have thought about it is, you know what, let's just roll the first die. It's going to have some number on it, right? The first die is going to have some number on it. Now, in order for me to have doubles, the second die has to have that same exact number on it, right? So I don't care what the first die gets. It could be a 3, it could be a 4, it could be a 5. I don't know what that is. But after that I've rolled that first die, in order to get doubles, what the second die roll is, they might be almost simultaneous, but what the second die rolls matters. And so whatever number I have, on the first die, there's a 1/6 chance that the second die is going to have that same number on it. So that's another way of reasoning that you have a 1/6 chance. First die does anything it wants, but there's only a 1 in 6 chance that the second die is going to have the same thing as the first die. Either way, you get to the same 1/6 answer.